Hello, so today we are going to do this problem called power xn. So just as we want to implement a power function that calculates x raised to some power, and this is basically the examples, right? So actually, I would have preferred if I can like solve it with binary search, just to practice it a little bit. But other than that, we can just do for a brute force solution here would be basically we can have res here starts out as x, right? Pretty much we can do this, right? But this would be oven. Let's first see if this passes, right? Just as a quick. Then res here. Then we can just return it. Yeah, it's a little bit above like what I'm looking for, so this should work. Okay, so that works. Now, does it get time limit exceeded? So binary search, if we can do it on the n, we can do maybe of like n. Or maybe we could just like so we have a problem here with this case. With -2, right? Okay, so when n is negative, we have a problem. Yeah, I think I could do if n is less than 0, just say, yeah, I should have tried the test case here. Just use the same function and pass in 1 divided by x and minus n. Maybe we can do divide and conquer, right? Yep. I think that would be better. Oh, I need to return this actually. So okay, so that works. So this technically should work, unless we get time limit exceeded. And then with this solution, I would do basically, yep. So this one I need to test with this one as well. So basically, these are my test cases. Okay, so these are the test cases that we are going for. And then here we can do for x, right? We can do just the results so far. We can do n divided by 2, right? And then just multiply by the same thing. So we can have this, and then we can just return this multiplied by 2, right? We can calculate half just one time, right? So to do this, we can have maybe prod equal to product, essentially. So, or let's call this half, right? And then we can just return a half multiplied by half, right? Will give us the same thing. What I'm trying to say is x to the power of n divided by 2 multiplied by x to the power of n divided by 2 should just give us x to the power of n, right? Okay, so first let's try to do it with this. And this would be self-dot. Okay, if n is equal to 1, otherwise we will just keep dividing, right? So when n reaches 1, then we can just return x, right? Actually, I think it's all I need is this. Now, we can do if x modulo 2 is equal to 0, we can just return this. Else, return -1. And properties, I think I even find. Somehow I'm forgetting this. So let's try. So if it was like this, right, then this is just x to the power of 2 multiplied by x to the power of 2, right? Because let's say, for example, we had 2 to the power of 4, right? Right, so let me do the Python, right? So 2 to the power of 4, right? That's 16. 2 to the power of 2 is this. 4 multiplied by 4 is just 16, right? So this should work. Like x to the power of n of 4 is just x to the power of 4 divided by 2 multiplied by x to the power of 4 divided by 2, which is 2 in each case. So it's just n divided by 2, and here n divided by 2 as well. And this is x to the power of n, right? And this is, of course, if it's if x is, so yeah, my problem is this. I need to check for n, sorry. Okay, so that works. Now if I try this one that got limit time exceed, now we should be of log n now. So now it should be of log n, and if I try this case, this should work. Okay, let's try to submit. Okay, except when n is 0. So when n is 0, we should return 1 as well. So if n equal to 0, just return 1. Now, if n equal to 1, it would be here. It will come as, right, x 0 divided by 2. So this would be 0, so it should return 1. So we'll multiply by x. So I think we can skip this one. And the last one is this one. Cool. Okay, so that passes. Yeah, so this is not binary search per se, but it still gives us open. Cool. Okay, so we can actually do this in a little bit of a better way, which is instead of like multiplying the product result, we can just multiply by x here. That will give us the same thing. That will give us the same thing here. So we could do just this. It should be enough, right? And then if it's add, we can do something similar, except in a similar way like what we were doing before. So it's a return here, and it needs to be x multiplied by this, except here we will do n minus 1, right? And that should give us the same result, right? Another thing we can do here, yeah, I think that should work. Let's try it. Let's just put this first though, just so that at the end we can have just calls to the recursive calls at the end. Okay, cool. So this works as well. Yeah. I think this is it for this problem. Thanks for watching and see you in the next one. Bye.